department Deepa Rajan ma'am and event coordinator Grishma ma'am from Bishop Jerome Institute, and I would like to welcome our founder and CEO of Pencil Bits, Dr. Sangeeta Subramanian ma'am, who is constantly organizing these kind of events. I welcome you, ma'am. Uh, I would like to call Ms. Keetna ma'am to deliver her presentation, please, ma'am.
Yeah, thank you. Thank you, Kartika. Good morning, everyone. So today we are going to see computational approaches of problem solving. Let me share my PPT first. Is it visible to everyone? Can you unmute and say yes? Is it visible?
Yes, it's visible.
Yeah, thank you. So, hi everyone. So today we are going to see computational approaches to problem solving. In this computational approach, there are varieties of algorithms are there. So we are going to discuss today about a brute force approach, a divide and conquer approach, dynamic programming approach, greedy algorithm, and randomized approach. So in morning session, I will be covering brute force and divide and conquer approach. So the rest of three techniques will be covered in the afternoon session. First, what is a brute force approach? Actually, this brute force is applicable to everyone. So, either a person is developing a program, he has to consider this brute force. Either a hacker is hacking any passwords, so he will be following this brute force. It is a very straightforward approach. It is usually it depends purely depends upon what are the problem statements given and what are the definitions involved in the problem statements. It means that what are the solutions you are going to provide for that respective problem. So for example, if you want to come a power n, a should be always greater than 0, and the powers of a should be always a non-negative integer. It means that a positive integers. For example, 2 power 3, 3 power 4. So like that, you can split up the powers in terms of, suppose you are considering 2 power 4. I can split up my powers as 2 power 2 into 2 power 2, or 2 power 1 or 2 power 3. So for these combinations or differing in every iterations, it means that we are going to follow a trial and error method approach. So this is one of the example of brute force. So the second thing is, if you are computing a factorial of a number, so this also involving a brute force approach. For the third thing, if you are multiplying any two matrices, or you are multiplying any powers of two numbers, so these are based on brute force approach. uh, Suppose you are having 100 numbers, you are going to search a number from that list. So that also based on a brute force approach. So the behind concept is brute force approach. So based on that brute force only, the computational power of your problem is estimated. So there are two mechanisms going to discuss here mainly. So first thing is padlock, and second thing is a password guessing method. So what is a padlock? A padlock, it is a device. It is a mechanical device. It is used to find what are the number of possible combinations that you can use for unlocking. Either it may be a password, or either it may be a device. For unlocking the device, a padlock is used by getting the input by means of trial and error. So this involves in testing every possible combination in a sequence. It means that those possible combinations are decided based on trial and error. If you are trying one combination, if it gives an error, then we are moving to the next combination. So that is based on a brute force approach. So there are common two types of padlocks. First one is a combination padlock, and second one is a keyed padlock. Combination padlock means how many number of sequences, that is how many number of specific sequences or symbols involved for unlocking the device. That is a combination padlock. So key padlock, it means it uses only the physical keys. In this, where the brute force is involved means, so various number of key cuts. So for unlocking a lock, you will be using a physical lock, you will be using a key for unlocking that lock. So that instead of trying with a single key, so the multiple keys are tried. It means that they are also involved that trial and error approach. So, so next one is, what are the steps in brute forcing a combination padlock means? So first thing, identify a lock type. What is the type of a lock you have used? It means that most combination padlocks will have a dial or buttons for unlocking with a limited range alone. It means that if, for example, considering a range of 0 to 39 for three types of dial padlocks. So this is the method for identifying the lock type. So the second thing is calculating a possible combinations. How you can calculate a possible combinations if we are involving a three dial padlock? It may be involving, suppose you are considering 0 to 39 iterations, means the number of iterations will be 40. So you will be multiplying that 40 into 40 into 40 means 64,000 possible combinations are involved for finding out which key is suitable for that lock. So the third thing was attempting every combination. You have to attempt each and every possible combination for unlocking it. So that is known as attempting every combinations. It means that, for example, we have, by considering 0 to 39 for three dialogues, you may be involved with 64,000 possible combinations. Then the possible combinations will be starting systematically from 0 to 63,999. So that's up to like that the trial and error method will be going on. So, what are the challenges you are facing while involving this type of padlock? Means first one is time complexity. So, time complexity means if you are considering the same thing, three dial padlock means I have said that 64,000 combinations are involved. So, those 64,000 combinations we are going to try, it is very impossible method and it is also very complex method. It will taking a more time. So it is very impractical for complex padlocks, right? So that's the time in complexity is the major thing is to be considered in a padlock. So the second thing is security mechanisms. What type of security mechanisms are involved in a padlock? Suppose some padlock will have some mechanisms, so that will be allowing the user out of multiple failed attempts. If you are trying trial and you are getting error or multiple errors, or you are getting means, so then the brute force approach is will be harder for those kind of padlocks, right? So these are the challenges we are going to face while we are using a brute forcing technique in a padlock. So the same thing I have said for considering three dial locking. By considering this example only, I have described those challenges. So second thing is how you are going to apply on brute force technique on a password. Simply consider a Gmail password. So it will be asking you to enter a password with a combination of letters, numbers, and symbols in Gmail, right? It means that if you are entering those combinations of passwords, then your password will be very strong. Otherwise, it will be weak. So if you are having those combinations of passwords, so this will be very difficult for the hacker to breaking down your accounts or breaking down your systems. So some in some forums they will be allowing you to enter above 8 characters or above 9 characters. Those 9 characters should be with either combinations of letters, numbers, or symbols, or uppercase or lowercase, so underscore letters. So they will be forming their own set of rules for setting up your password. So the password structures will be like this. You can use the alphabets, either it may be uppercase or a lowercase or a combination of upper and lowercase, and it should include a numericals, that is 0 to 9. You can use any combinations of numericals in your passwords. So third thing is a special characters, exclamatory, at symbol, hash, dollar symbol, or upper caps, or star, plus, minus. You can use etc. You can use any types of special characters in constructing your password. So in which way the brute force is involving here? So the first thing, how the hacker is enabling the brute force for finding the passwords. First, they will be identifying the what types of character set are involved in this. For example, if your password is only with the lower characters means, so there will be a hacker will be very happy and he can attempt only the 26 combinations. Why means the alphabet letters are 0 to 25, that is 26 letters, so he can attempt the combinations of those 22, 26 letters. So the total combinations will be what? 26 power 4. So the according to the hacker point of view, so these are very automatic systems. It means that so those combinations will be attempted by the systems. It will be pick up faster for finding what is your passwords. So second thing is systematically attempting the passwords. Suppose you're having a password of similar combinations like a continuous of only A or a continuous of only C. It will be easily find out by the hacker by incrementally moving to more the most complex combinations. So they if at a point at one point if they have find that your password is only with a similar combinations, it will be easy for them for find outing the passwords. So what are the challenges? The same thing, what are the challenges of involved in brute forcing the passwords? So first thing is time complexity. Second thing is accounting lockouts. So third thing is hashing and encryption. So what is the time complexity is involved here means, suppose if your password is very strong, uh, time will be requiring more for finding out the complex set of combinations. So it means that if you're having a 6 character password only with the lowercase letters or only with the uppercase letters means, then the hacker will be following the same types of combinations, that is 26 power 4 combinations, for finding out what is your password. Suppose your password is a combination of letters and numbers and symbols means, it is very a little difficult for a hacker to find what is your password. So it will be becoming a more complex task for the hacker to find out the exact passwords. The second thing is account lockouts. For many systems are implementing a lockout process for if the certain number of attempts of passwords are failed or login attempts are failed, this will be more difficult while following the brute force approach for accounting the lockouts. The third thing is hashing or encryption. Suppose if you are entering your password, so that password is hashed or encrypted and it is getting stored in your data center means, it will be more difficult for the attackers to take up the reverse engineering processes for guessing your passwords. So these are the challenges involved if you are taking up brute force approach for guessing the passwords. So the next thing is optimization techniques. What are the techniques involved here? So the first thing is dictionary attacks. This the first thing is dictionary attacks, and second thing is rainbow tables, and third one is parallel processing. So first one is dictionary attacks. Instead of trying every possible combinations, this dictionary attack helps the attackers to find out the common words or phrases. It means that if you're keeping your name or your favorite place in the combination of your password means, this will be attempting using a dictionary attack. It means that a brute force will be making a friendship with the dictionary attacks to find out, yeah, what is your passwords. So this will be again very less effective while we are having a strong combination of passwords. If you are having a weak combination, it means that either you are having your password with a letter or a symbol or a number, but your password combination is weak, means so dictionary attack will be more efficient for finding out the exact passwords. So the second thing is rainbow tables. This rainbow tables or pre-computed tables. It means that it uses the hashes. Hashes means possible combinations of a password that can user keep will be maintained using one table. So these type of pre-computed tables are used to crack the hashed passwords very faster. Rather than using the dictionary attack, an attacker will be moving to rainbow tables for easy guessing of strong passwords. It will be speeding up the process for guessing your passwords. So the third thing is parallel processing. It is also known as a modern brute force approach. It uses a multi-threading process. It means that one side uh, you will be running up the normal brute force. The same parallelly you will be running the brute force with the dictionary attacks, and the same you will be running up the dictionary rainbow tables along with the brute force attacks. So these three things will be running at parallelly. So it will be ensuring the saving of time and increasing the speed of the attack also. So I have already said if your password is a 8 characters, it is a combination of it means that uppercase. If a character is long, it includes uppercase, lowercase, numbers, or special characters. It means that if your password is strong, means so these four combinations of a password, how more effective you are combining your password. That is the first thing. So this can be guessed using a brute force by involving a combination of optimization techniques. So the next thing is sorting. Selection sort by the brute force. So uh, hope you are all aware of what is a sorting algorithm. It means that if you are having a set of 10 integers with a mixed combinations, you have to sort those numbers. So that is a sorting. So what is a selection sort? Means suppose if I'm having 7, 3, 2, 5 as my number, means selection sort will be comparing first two numbers. If it is unsorted, sorted. Again, next two numbers. If it is unsorted, sorted. And next again these two numbers. If it is unsorted, sort it again. So in this way, the selection sort will be following up. So how long it will extend means 0 to n minus 2 up to 0 to how many numbers minus 2. It will be following this algorithm. So this is the algorithm of a selection sort. It will be extending up to first zeroth element to n minus 2. First, if minimum element is found, it will be allocated to the minimum variable. So again, the for loop will be extending up to throughout an array. If it is any unsorted combinations, you will be sorting and swapping away. So what is the time efficiency of the selection sort? Since you are doing two types of approaches here, it means that you are comparing, and swapping. So comparing and swapping, so two mechanisms are involved here, so that the time efficiency will be order of n squared. As we discussed this orders, that is big word notations in module 2, I think, time efficiency and space efficiency. So here, while the space efficiency is the order of 1, means here the sorting is involved throughout the array. So it means that only one array is involved while you are running this algorithm for one time. So that's why the space efficiency is order of 1. So this is an algorithm of selection sort. So the second thing, string matching by the brute force. If an attacker want to find out what are the messages your what are the messages you are involving in your email means, first the two things are to be considered. The first thing is a pattern and second thing is a text. A pattern means it is a string of m characters. It means that in which pattern the strings are represented for searching. Second thing is, a text means how long a string is extended. It means that it can be a single line or two lines or it can be a paragraph. Okay, so what is the problem here means I want to find out the substring present in your string. It means that I have to guess a single word from your line. So then and there, for this mechanism, it means that for this problem, I'm going to apply the brute force technique for finding out the text from your line. For this thing, first the step one is to be followed is you have to align a pattern at the beginning of the text. So the second thing, you have to traverse throughout the line from the left to right words. So by comparing each and every character which is matching your fixed substring. If mismatch is detected, so you have to traverse through the string. It means that you have to continue through the paragraph until you are finding out the matching characters. If the characters are matched, then this brute force will be becoming more successful technique for finding out the string matching. So until the string is not matched, you have to repeat this step 2. So that is represented in a step 3. So for example, if my text is a binary digits, I having the pattern is this, I have to search. This means you will be applying this pattern from the 0th position to the last position of the bits, at which if double zeros are found. So if double zeros are found at the second position means you will be traversing. But here there is no last digit is matching here, so it will be again traversing, so it will be looking for double zeros. So here it will be getting stopped, here again it will be double zeros, but the fifth digit is not matched. Again here it is double zeros, so 1011. So this is the pair is matched. So here the brute force will be getting stopped and it will be matching the pattern with the text. So this is the type of brute force is applying for string matching. The same concept you can apply for a sentence also. If my pattern is a happy, it will be going on searching throughout the line where the happy is found. So it doesn't match, is it doesn't match, never is doesn't match, to doesn't match. So goes on happy, it will be matching. So the brute force is succeeded at this stage. So this is an algorithm of string matching. So you will be dividing, if you are having a more paragraph, those more paragraph will be divided into two. So that is, if you are having a complex problem to solve, just divide that complex problem into modules. So you will be applying this brute force string matching to each and every module. So you will be applying for each and every module for getting a successful search of a string. So the efficiency will be calculated as time and space efficiency. So same thing, you will be dividing the complex problems. The time efficiency will be order of n square and space efficiency will be order of 1. So these time and space efficiency will be purely based upon what are the operations and what are the data set you are taking in for solving your problem. So this is a looping for traversing throughout the string for string matching. So until it will be traveling up to n minus m. N minus m means if you are dividing your array in so n will be your last string present in your text, and m will be your the what is the text present in your pattern. It means that it is a length of a pattern, and this will be your length of your text. So it will be going upon um, j lesser than m, and this condition is satisfied until this two conditions are getting it means that will be your position of your string. It means that a b, this will be your indexing will be 0 and this will be your indexing will be 1. So each and every letter present in your text will be considered as an array. So that's why this algorithm was also written using the arrays. So the next brute force approach is a polynomial evaluation. It means that for solving a polynomials also, the brute force technique is very useful for evaluating for given polynomial. Suppose this is a standard formula for your polynomial. So n will be your non-negative integers and this will be your polynomials, and a will be also your numericals, and x will be represented as x or y. So this is a brute force algorithm for evaluating the polynomials. So powers will be always set to 1. So if the powers are increased, so depending upon the powers, so here the powers will be getting multiplied. So in this case, these polynomials will be solved using this brute force algorithm. So this is an improved polynomial evaluation. Suppose you are having a left and right two equations has to be get satisfied in the polynomial means you will be using the Horner's method for evaluating the two equations, that is LHS and RHS to be getting solved in the polynomial means you will be using this Horner's method for evaluating the polynomials. That this brute force is handing up with the help of Horner's method for solving these kind of polynomials. So the same algorithm is to be followed here. The only thing is, so the power will be allocated as an array. Here the power will be allocated as initially as a 0. So this is the only thing, um, only difference for Horner's method and normal method. So the next thing is closest pair problem. If any points in a graph you are plotting up, so these are considered to be a closest points or farthest points in the graph. So that can be used to find using a brute force algorithm. So if you are placing any 2 points in a graph means it is represented as a Cartesian plane. It is mostly we call it as two-dimensional Cartesian plane. So those 2 points can be find out using a brute force approach. For that one, you have to find out, suppose this is a Cartesian plane, I'm having 2 points here. You have to compute the distance between the 2 points present in the Cartesian plane, and you have to return the indices of these 2 points, and you have to find out which is the smallest one. So which is the smallest one? If you find out easily means you can find out the uh, which are the points are very closest in the represented in the graph. So this is an algorithm for finding out the Cartesian points closest to pair. So here these are the inputs. So the points are represented as x and y coordinates in the graph. You can represent it up to that is x1 comma y1 or x2 comma y2. It will be going on extending up to xn comma y1. So what is the output will be means? So this index 1, this will be considering as an index 1 and this will be considering as an index 2. If you want to find the closest point means first you have to find out the distance between. So what is the distance formula? You have to take out the square root of these 2 points, that is square root of 0.1 the square plus 0.2 the square. If you're finding out the square root means, so that will be your distance calculation. If that distance is lesser than the mentioned distance, then these 2 points are said to be a closest points. So that you will be then returning what are the points are closest to each other. So that will be your output from this algorithm. So how can you find out the efficiency? So the efficiency can be find out based on the time. Same also here, based on the time and efficiency. So what is the advantage means, while using this brute force approach for finding out the closest pair, it saves you the time for a manual execution. So how it can be made faster? If you are using a logarithmic of n values of the points means, this algorithm will be more effective and it will be more faster. So the fourth thing is the complex hull algorithm. What is a complex hull? Here, for each brute force algorithm, so all the points you have to be taken to one side. So if you are taking it to one side means the complexity will be n power 3. So if you are taking on the another side, so the improvisation of an algorithm will be can be represented as average case and worst case. If it is an average case, it will be simply n. If it is a worst case, it be n squared. If it is a best case, then it can be represented as n cube. So the fifth one is exhaustive search in a brute force algorithms. So mainly brute force algorithms for finding the closest pairs in a Cartesian plane. So the thing is exhaustive search. What is an approach used in the exhaustive search means, you will be evaluating all the solutions and you will be keeping it in a list. That means that you will be storing it in a list. That method is known as enumeration. So you will be, first thing you are what is going to do, you will be evaluating all the solutions. It means that you will be finding the distance between the all the points, and you will be keeping those results in the enumeration, and you will be choosing an appropriate solution, which is the smallest one. So this is an exhaustive approach. So this exhaustive approach is very effective, but the one disadvantage is very slow approach. It means that you will be evaluating all possible solutions and you will be keeping as an enumeration. So that's why this is very slow approach. So here the brute force of how it is taking up the exhaustive approach means, it will be taking a computational objects, that is combinatorial objects such as permutations, combinations, or a subset of a set. It will be enumerating all the results, right? So what are the permutations or permutations means, you will be having some set of tables, fixed tables. You will be applying these solutions in the tables for finding out the seamless solution. So second thing is a combinations means, what is a combination pair you are considering in your array. The third thing is subset. You will be dividing your sets into subsets. It means that you will be dividing into modules by, and then you will be applying this permutation technique for your submodules and finding out which is an appropriate solution using an exhaustive search. So exhaustive search, there are some examples I have represented. I have represented these examples. But if you are considering a graph algorithms, a DFS and BFS is also will be coming under the exhaustive search. So depth first search means it will be searching for all the nodes in a graph. Breadth first search means it will be visiting all the connected nodes to a node. So this is this I'm not going to discuss today. So I will be discussing these three problems in an exhaustive search. So the first thing is traveling salesman problem, snapshot problem, and assignment problem. So these three things will be discussed today. So more best algorithms is also available in the net. You can refer that also. So the first thing is traveling salesman. It means that, so this traveling salesman algorithm will be represented as a graph only. So each and every graph, it will be having its own distance. It means that for reaching from A to B means my cost is 2. And for reaching from B to D is my cost is 4. So I want to reach from A to D. I can reach directly if it is a link, or either I can reach through B also. So if I directly reaches, my cost is 5. And if I reach through B means my cost is 6, which is the least cost. So that will be my more appropriate solution. It means that it is following a technique called Hamiltonian circuit for finding out which is the shortest path of a present in an algorithm. So this is just a concept called Hamiltonian circuit. So this Hamiltonian circuit concept is followed by the traveling salesman problem. Here every nodes are considered as a cities, and this is considered as the cost for reaching the cities. So see here, this is a tool A to B to C to D and then A. See here, A to B, B to C, and C to D, and D to A. So this path is possible. It means that it is combining all possible combinations. So all possible combinations have to be considered. So the second thing is A, B, D, C, A. A, B, D, C, A. This is one of the possible combinations. So you have to consider all the possible combinations in a network, and you have to find out the cost for each possible combinations, and you have to enumerate it, right? So this possible combinations, I'm adding up the cost, it will be 17. So next possible combinations I will be getting added up, this will be 21. So the same thing for I'm considering the 6 possible combinations. So you have to check whether you have considered all the possible combinations, or you have to consider more, you have to check. Okay. Um, so in this, which is very minimum cost, so you have to consider that. So like, this one is the one of the minimum cost, and this one is of the minimum cost. So that is A, B, C, D. A is one of the possible combination, and A, D, C, D, A is one of the another possible combinations with a minimum cost of 17. So should I consider more? You have to check again. So how the efficiency will be calculated as, so the number of permutations you are handling are, so how many number of permutations in all combinations you will be having, that is BCD. It means that in all combinations you will be considering BCD in another place. So the efficiency will be as order of, that is big O of n factorial will be your efficiency. So if you want to consider few more combinations, if it is needed, you can reserve and you can enumerate it. So this is a traveling salesman problem. So what is a snapshot problem means? For example, you will be considering here weights and values. What are the weights in traveling salesman problem? We have considered as a cost. So instead that cost here it is represented as a weight. And what is a value here? It can be represented as a cost here. So these are the weight means what is the weightage of a node it is represented, and this 1, 2, 3 all will be node. So each and every graph is represented as a table here. So the common weight capacity, snapshot capacity, one of the integer W is considered here. So that will be 16. So based on this table, I will follow the snapshot problem. Here, what you have to enumerate means you have to enumerate the possible set of subsets. It means a possible set of combination of items. So the first subset is containing 1 separate, 2 separate, 3 separate, and 4 separate. So the second thing you will be considering a set of 2 coordinates. That is, 1 how to match with all the other 3, and 2 how to match with all the other 3. So while matching all the other 3, if I'm matching again with the 2, so I have already have the subset is 1 comma 2. So that 2 comma 1 will be not considered. So the same thing will be followed for 3 comma 4 also. So while considering 3, I will be having 3 comma 1 and 3 comma 2, but I already have the same set with a different combination, that is 1 comma 3 and 2 comma 3. So that two before subsets will be omitted. So then again you will be considering a 3 set of subsets with the different combinations, that is 1, 2, 3 and 1, 2, 4, and 1, 3, 4 and 2, 3, 4 will be. different set of combinations. So again, we will be considering two subsets. So the total weight you have to consider. What is a single weight of one? It is 2. So that is represented here. And what is the weight of 2? 5. It is represented here. And what is the weight of 3? 10. It is represented here. And what is the weight of 4? 5. It is represented here. The same thing will be having the total values. So while comparing 1 and 2, so you have to add the total weight of 1 and 2 and you have to represent here. Same thing for the cost also. You have to add these two costs you have to represent here. So 1, 2, 3 means you will be representing 1, 2, 3. It means 17. So I will represent as a 17. So while adding the cost, it will be more. So that's why I have represented as a not feasible thing. So the same thing if it is while calculating, so the maximum weight is 80 means if you are getting more than 80, it will be not feasible. If it is getting a less than 80 means it will be a feasible value. So efficiency, how you will calculate means this efficiency is purely based on types of subsets. It means that how many types of combinations you are going to perform. So the big that the efficiency of this snapshot algorithm will be represented. So the third one is assignment problem. How the assignment problem will be very useful means in operating systems. We are solving the jobs. It means that in every operating system, for example, here Windows is my operating system means I'm opening a PPT means that is one job, or I'm opening my Google Chrome means that is one my another job. So every actions you are performing in your operating system will be considered as jobs only. By considering, imagine that one as your jobs, and here I have represented an example table. Suppose person 1 is performing job 1, job 2 and job 3 and job 4 with a cost of 9 rupees. So person 0 is performing the job 0 with a cost of 9, and person 0 is performing the job 1 with a cost of 2, and person 0 is performing job 2 with the cost of 7, and person 0 is performing a job 3 with a cost of 8. The same thing as for person 1. So job 0 is 6 rupees and job 1 is for 4 rupees. It can be in dollars also. Anything, any representation we can keep it. So job 2 is for 3 rupees and job 3 is for 7 rupees. So for same thing for person 2, 5, 8, 1, 8. Again for person 3, 7, 6, 9 and 4. So how the algorithm works means you have to perform what are the possible combinations of assignments you can take, and the second thing you have to compute the each and every cost of each and every jobs and each and every persons. You have to select which is the cheapest one. So same as the in the snapshot for traveling salesman, our aim is to uh, our aim is to achieve which is the shortest or which is the minimum or which is the cheapest one. So the same thing is to be followed in an assignment problem also. You have to select which is the cheapest form of a job is performed by the person. So here I'm taking as a matrix form. So I will be representing as a matrix form. So I will be taking the assignment combinations as 1, 2, 3, 4. It means that these are the jobs. Okay. So I'm having these possible combinations. Suppose 1, 2, 3, 4 means I'm having these one as a possible combination. And again 9, 4, 8, 9 is my 9. 8, 9 is my one possible combination pair. So each and every combinations of a person, it means that which is the minimum cost of each and every job I have to perform it. So I will be checking up all the possible combinations and it will be going on and finding out which will be a minimum cost. So this is an assignment problem here. So by finding out, so which is the minimum cost I will be performing. So by continually I'm doing this kind of assignments, I will be achieving our 2, 1, 3, 4 combinations. I will be getting in the minimum job. So how many assignments? So how many assignments I can make means it can go up to n factorial. So up to n factorial, these kind of assignments will be going on. So these kind of assignments will be going on up to n factorial. So what will be how you are finding using a cost means, so each and every row and column you will be each and every row and column you will be finding or you will be taking only one cost. I should not take nine like this. I should not take like this. I should not take. You can take it as like this one or this one. Like this, I can take. It means that each and every row, I can take only one numbers. It means I can take only one cost. So this exhaustive search you are applying on every applications. It will be giving you only small amount of time execution. So these exhaustive search, instead exhaustive search, what kind of algorithm I can apply on these techniques means you can apply Euler circuits or shortest path algorithm or minimum spanning tree. Minimum spanning tree will be following up algorithms such as Dijkstra's or Kruskal or Prim's algorithm. These are known as a minimum spanning tree algorithm or assignment problem. In assignment problem also you can apply um, this exhaustive search also. You can apply same assignment problem technique on any other complex problem also. So the second thing we are going to discuss is divide and conquer technique. So divide and conquer technique, as the name suggests, you will be dividing your main problem into module by module, and you will be applying your solution for each and every module, and you will be combining the results. So this is a divide and conquer technique. And it is one of the famous problem solving paradigm in computer science fields or mathematics fields also. Divide and conquer is ensuring a very effective searching algorithm. So it means that you are breaking down the problems into smaller problems. It means that sub problems. So you will be applying each and every problem in a divide and conquer technique. So 1 minute, I'm getting so please reduce the speed. Okay, okay, fine. So in divide and conquer technique, so this technique can be applicable for mathematical problem solving also. So in when it can be applicable for mathematics solving problems, you will be having a sequence of problems. So those sequence of problems are divided into sub problems, and you will be applying your solution for each and every sub problems. At the final stage, each and every solution of a sub problem will be combined together to form an original solution. So this method is effectively solving a problems in a recursive manner by dividing into a similar subproblems. In this divide and conquer technique, we are going to discuss a merge sort. So it is one of a very effective sorting technique. It means that this is a diagram is representing a merge sort only. It means that first I'm having a 8 numbers here means I will be dividing these 8 numbers by n by computing as wait a minute. I'm having a divide of n numbers means that is n numbers, you have to divide it by 2. It means that suppose 8 numbers means 8 will be divided by 2. It means that 4. I have to divide initially my problem as 4 numbers. So after that 4 numbers, I have to my number now my n value is 4. So again you have to apply 4. 4 divided by 2. It means that 2. Again, this problem will be dividing by 2 by 2. So again, I have, now my n value is 2. 2 divided by 2 equal to 1. So again, these two values are divided into single values. So now a single subproblem of 8 numbers will be divided into 4 pairs, and you have to apply a sorting. So you will be comparing these two, and you will be comparing these two, and you will be comparing these two, and you will be comparing these two. After comparing these, you will be sorting. Initially, my subproblems will be 7 and 2. So 2 will be sort to 7 and 2, 7, and again uh, 4, 9 will be here. After sorting, I'm saying again 4, 9. So again, you have to combine these two problems. After combinations, you again apply your solutions. So now the initial value will be having as 2, 7, 2, 7. So you will be applying the sorting means 2, 2, 7, 7. Again, here 4, 4, 9, 9. So again, you have to apply the solution for whole set. 2, 2, 4, 4, 7, 7, 9, 9. My solution is achieved. This is the method. So we are going to see detailing what is an algorithm, what is the steps in algorithm involved in a method, and excuse me, what is an algorithm involved in a method, and what are the advantages of a divide and conquer method, what are the disadvantages involved in a divide and conquer method. So this is a general algorithm of a divide and conquer. So first thing is dividing, then recursing, then conquering. So dividing your problems, applying a solution for your subproblems, and again applying your subproblem solutions and applying your solutions again. So you have to divide the input data. If you're having the S data or N, it can be represented as N also. You will be dividing and applying solutions, and you will be combining the solutions again. So this is a diagrammatic representation of a divide and conquer. So the base case of this divide and conquer method is the recursion. Recursion means you're applying the same solution on each and every subproblems. It means that if any function is called for many number of times, means it is known as a recursion. The same thing if you are applying a same solution for each and every problems for many number of times means here recursion is a base case of divide and conquer. This is how the analysis can be done. Here, analysis can be done how much the recurrent functions are called based on your problem defined. So based on that only, the analysis will be calculated. Analysis means your performance analysis by means of time complexity and space complexity. So this is a typical method algorithm. So you will be having a set of sorting numbers means you will be initially you will be dividing your total number of inputs into partitions. That is, you will be dividing your partitions as n divided by 2, and you will be applying a set 1 and set 2. You will be applying method separately, and then you will be combining these two, and you will be providing a solution. So here in what is your contour, you will be merging these S1 subset 1 and subset 2, and you will be providing a final solution. How much partition you have to do? So that is n minus 2. Partition section will be recursively called here for dividing the partitions of each subproblems. So again and again, we will be calling this merge sort function by applying your partition and applying your comparator. It means that it was subproblems. And in the final method, you will be merging your these subproblems and you will be providing a solution and storing it in a yes. This is your final method algorithm. So how the recurrence analysis can be calculated. So in the contour method of a method, you will be having a two sorted sequences, right? So those two sorted sequences will be compared each other and you can store the result in a linked list or in a doubly linked list or a singly linked list or any list you can store. So these are the types of data structures you are storing the solutions in a recurrence equation analysis. So here in basics, you will be considering n. N is your total number of n is your total number of numbers you are taking for sorting. So if that n value is lesser than 2, it means that if n value is lesser than y, it is represented as 2 means you are partitioning into two segments in your method. So that's why here they have considered the parameter as a 2. If n is lesser than 2 means you will be reporting a basic as B. If n is greater than 2 means again you are applying a running time for dividing the partitions plus this. It means that suppose the initial case I'm dividing the partition into 2. Again this partition is dividing into 2. Again this partition is dividing into 2. Again this partition is dividing into 2, dividing into 2, dividing into 2, dividing into 2 means first case only I will be applying this one. For remaining cases, I will be applying this time complexity only. So in as like this only, the running time of the NetSort algorithm will be calculated. And the final solution will be stored it in T of n. So these are the algorithmic analysis of the MERSOT using their recurrence equations. So how you will be providing a solution. So that one we have seen using a recurrence equation. So this thing, rather than recurrence equation, if you are applying the iterative process means how that will be running means you will be dividing the you will be dividing here the second case again into 2, right? So this will be iteratively dividing. So this is based on this iterative process. So the first thing is again divided into n squared. Again it will be divided into 2 power 3. So again if this tab will be divided into 2 power 4. Again it will be going on 2 power 5 until it reaches the single digits. So this iterative process was known as a plug and chug technique. So this technique is known as plug. It is just name of this iterative technique. So these are the final case you are going. It means that in this way they are calculating the time complexity. So what is the time overall time complexity of this method means or order of n logarithmic of n will be your final time complexity of method. So recursion tree, how the recursion tree is formed means, so this iterative is detailedly explained here. So here, if n is lesser than n means, you will be taking as a base case, and if n is greater than or equal to 2 means you will be following the recurrence. You will be following iterative approach on this recursion tree. So this recursion tree is not. So first, initially the numbers you will be dividing it, and again you will be dividing it. So this will be your bn and bn squared. So it will be going on. So the total time will be calculated then as bn plus bn log n. So in this depth level, the size will be n by 2. In this depth level, the size will be n by 2 power I. In this size level, it will be going on. So see here, the final level will be IBN. So here in the final level will be your size I. This is your base case, and I into B base case into number of digits present in a algorithm. So another technique is also used in a method for finding out which will be your best time complexity. The third method is guess and test method. It means that trial and error. It means that it is following a brute force approach for finding out which is the best method. Here in best and test method, if n is lesser than 2, the same thing will be this. If n is greater than 2, you will be following guess and test. It means that each and everything will be divided by 2 and you will be taking a log of n. So here, C is finding out which case you are going to consider. So here, the time complexity is represented as C here. So you will be dividing this again. You will be taking logarithmic of n by 2. So again, you will be applying a logarithmic for C n by 2 and log n by 2. So while you are dividing this, so you are taking common factor as C. So C will be a common factor and n will be a common factor. Then you will be applying log here, and already you are having a n log n. So this becomes log 2. So again you will be multiplying cn inside. So your logarithmic factor will be cn log n minus cn plus b log n. So why here cn log n we didn't write means, so after applying, so log n will be the common factor. So that's why we have, so log 2 is 1. So that's why we have written as cn alone. So again, you are applying guess and test method in another approach by taking a squares of logarithmic n means you will be applying a log square for each and every factor, and you will be getting multiplying it. So again, you will be multiplying here C n by 2 and log square of n by 2. So you will be taking the common factor of C, and so then they will be becoming as log n minus log 2 the whole squared. So again, you will be multiplying C n inside. So log 2 will be 1. So C n log squared n, and log 2 will be 1 means, so another one log is there. So 2 into Cn log n. So again Cn here. So this you are applying a minus b the whole square. It means that a squared plus b squared minus 2ab. So this is 2ab, this is a squared, and this is b squared. So commonly we are going to written it as Cn log square of n. So then here, if you are using in this case, the time complexity will be order of n log square n. So the third after method, we will be seeing simple integer multiplication using a divide and conquer method. If you are having more than two integers, it means that suppose you are having 2, 3, 2 into 1, 1, 1. Here I'm having a three-digit numbers in first set, and I'm having three-digit numbers in the second set. How we are going to apply the multiplication of an integer algorithm over here? So the first one is you will be dividing as I and j. It means that higher bits and lower bits dividing. So you have to divide the bits of the integer as a higher bit or a lower bits. So the higher bit value will be divided as IH 2 power n by 2. These are very fixed formulas. You cannot change these parameters. You have to apply these predefined representation of divide and conquer parameters on your problem solving. So these are all statically defined already. So I, the lowest of h and 2 power n by 2 plus I into L. L will be your total length. Again for higher bits, sorry, lower higher bits is I and lower bits is J. So this is represented as J H 2 power n divided by 2 plus J L. L is a lower bit and H is a higher bit. So again you will be multiplying these two factors. You will be multiplying all these two. I will be getting this. So this will be your final. After adding up these one, you will be getting your final result. So the time complexity is represented as 4 into y 4 into means I will be having the four final parameters. After combination of four final parameters, you will be having the resultant time complexity value. So which is implied as the order of n squared. But this is very a complex algorithm while you are following for two sets of integer multiplication, as it will be taking more time because it is dividing the bits into lower significant bit and higher significant bit, and after that they are multiplying and adding up. So that's why it is considered as a very complex method for multiplying the integers containing more than one bits. This is an improvisation of the previous algorithm. So the improvisation, how they can be done as, so how they are multiplying as, they have taken as a common factors of I, j and 2 power n, and after that they are splitting up the powers, and after they are conquering, it means that they are combining the techniques. So here they will be getting multiplied, and the common factors are taken as a common factor. So after applying the solution, you will be conquering the final resultant as IH, JH and 2 power n. So this is your final resultant. So this time complexity as order of n power logarithmic of 2 power 3. So this is your time complexity. So this application is known as Master's theorem. You are applying a Master's theorem here. So again, after taking a logarithm of 2 power 3, the time complexity can be written as n power 1.585. It means that this is a time complexity of this algorithm while applying your master theorem for improvisation of integer multiplication in divide and conquer. So what are the advantages? The first thing, it while considering divide and conquer method for solving your problems, you can achieve improved efficiency. It means that it can often reduce the time complexity when compared on an iterative approaches. So in divide and conquer, while you are combining an iterative approach or a recursive approach, so it offers the time reduction. So this algorithm I have applied on a method I have shown. You can apply the same thing on quicksort, or quicksort is also one of the divide and conquer method. So same thing you can apply. If you're considering a large data sets, you will be achieving a better performance, and you will be getting a time complexity of order of log n. So the second thing is parallelism. So how the parallelism is achieved here in divide and conquer means, so I will be dividing the method into sub problems, right? So these sub problems are running parallelly and achieving your result. So this saves your time. So here the sub problems are running up parallelly, but they will be executing in an independent manner only. They will not depend on each other for execution, rather than they will be executed in a parallel manner. So for each sub problem, suppose we are dividing the sub problems into three. For each sub problems, there will be a different processes or different thread allocations for handling each sub problems simultaneously. Uh, for this one, thread 1 will be allocated. For this two, thread 2 will be allocated. For this three, thread 3 will be allocated. So here, while considering any windows or sorry, for considering any operating systems, so I'm working on a PPT means I can work parallelly on Microsoft Word also. So that is the factor of parallelism. So here in divide and conquer, this parallelism is achieving. So the third thing is simplified problem solving. So why it is simplified problem solving means, here you are dividing the complex problems into more sub problems, and if your problem is a non-manageable one means you will be dividing into small chunks. So each and every chunks will be operated separately, and you will be having more clean approach and more structured solutions for those kind of problems. So that's why here in a divide and conquer method, it is achieving a simplified problem solving. So the next one is optimal use of recursion. Here in divide and conquer method, without recursion, no divide and conquer algorithm can be achieved. So the natural process of divide and conquer method is a recursion. So within that recursion, iteration is also can be involved, as I discussed in the multiplication of integers. I have shown two methods, that is iterative method and iterative method involvement in a recursion also. So this technique will naturally making fit for all the problems while using a recursions. It will producing an inherent results at the final. So the next thing is betterment for dynamic input sizes. So it is not depends upon the input sizes how much length it can be. So whatever may be the length, this divide and conquer method is applicable for every complex problems. So suppose you are considering 100 digit numbers in a method means, so accordingly it will be divided accordingly, and it will be processed, and it will be providing a better solution. So in a real world scenarios, this will be very flexible. If you are using a divide and conquer, whether the input size is not known also, so this divide and conquer will be achieving a betterment of solutions. So next thing is reduced redundancy. What does redundancy means? In computational point of view, there will be a chance of getting a redundant computations. It means that one by one frequent combinations of computations. So for that case, each and every sub problem, that is each and every sub module of your main module, will be divided and it will be operated independently, and at the final stage the results will be combined. It means that uh, that then and there will be involvement of trial and error method. So for reducing such kind of redundancies, brute force approach is also involved, um, in combinations with divide and conquer. So in order to reduce the redundancies, in that cases, brute force plus a DMC or involved. DMC means divide and conquer technique. So, what are the disadvantages of a divide and conquer technique means? So, the first thing is overhead of recursions. It means that if you are calling a same function for running up in a divide and conquer for many number of times, means there may be a chance of occurring memory overhead. It means that here, every subproblem function is acting independently only, but they are executing in a parallel manner only. So, every parallel manner execution will be requiring different sets of memory. So, if they are requiring a different sets of memory, there may be a chance of overloading of a storage. It means that it will reduce the computational power of your divide and conquer method. So, excessive recursion calling in a DNCs will be lead to overhead of a memory. If, suppose if you are having only limited space for running your solution means, so this divide and conquer, if you are applying a major problem with a limited space, this will be causing this problem. So the second thing is a difficulty in combining results. Dividing a problem is easy, but combining those results is very difficult if your problem is more complex. So that's why this is considered as one of the disadvantages of divide and conquer. That is difficulty in combining the results. You cannot say divide and conquer is always the best approach. So that's why I have represented it here as it is always not an optimal solution. For certain problems, there may be a chance of occurring a overhead. It means that overloading of a space. So the combining of outweights of a problem is not a beneficial one. So for small data sets or for small set of numbers, you are applying this divide and conquer, it will be giving you the more optimal solution. But the same thing if you are applying on a more complex problems, it is will be not an optimal solution. So the fourth thing is repetitively subproblems. As divide and conquer, you are applying a repetitive procedure on your subproblems. So this will be considered as a boredom of problem solving persons. Some of the DNC algorithms may end up in solving the same subproblem at a multiple times if it is not carefully designed. Suppose while addressing in a dynamic program, dynamic programming will be discussed in afternoon session. So for that kind of thing, your DNC is not very suitable. For example, if you are considering in solving a Fibonacci series kind of thing, so this all will be discussed in afternoon session. So those kind of Fibonacci series, you cannot apply this divide and conquer method. So the last and before prior thing is a memory usage. So as I have already said, this divider and conquer will require more spaces. So while you are running this divider and conquer method, you will be having a maximum storage space in your system. So while considering your quick sort rather than merge sort, if you are going for a quick sort with the divider and conquer means it will be requiring more space when comparing to the merge sort. So that's why the memory usages mode is considered as one of more disadvantages in the divide and conquer. So as I've already said, it is not suitable for all types of problems. If it is a smaller problem, divide and conquer method is more suitable. If it is a complex problem, the divide and conquer method is not suitable one. So you will be having in your syllabus, mm, 1 minute. So in your syllabus, a brute force approach, they have considered only two examples, padlock and password mechanism. You can just refer that to alone. So for divide and conquer approach in your syllabus, they have mentioned met-sort algorithm only. So in met-sort algorithm, I have explained a simple maths for divide and conquer, and a divide and conquer with iterative approach, and a divide and conquer with recurrent approach. I have explained the three types of techniques, so you can prefer that also. So remaining thing, dynamic programming, greedy algorithm, and randomized approach will be discussed in an afternoon session by Dr. Madhumita. Um, Thank you. Any doubts in this? So these PPTs will be provided to pencil bits. You can get it from them. So in brute force approach, I have explained three extra problems. If you need, you can refer that also. I didn't explain DFS and BFS. So as it is not represented in your syllabus, I didn't go for that. So there are two topics only you can refer: padlock and password for brute force, and the method for divide and conquer. So any doubts? Any doubts? You can ask it in chat box, or you can raise your hands and you can unmute and ask. Any doubts? Okay. Kartika, are you there?
Yes, ma'am. Yes, ma'am. We can wind up the session, ma'am. Thank you so much.
Okay.
Okay, ma'am. Thank you so much, ma'am. And participants, thank you so much. You all can join with the same link for afternoon session. Thank you.
Um, I thank everyone for being patient for listening to my lecture, and I thank Pencilbits and Kartika for hosting this session and giving me the excellent opportunity to deliver my lecture. Thank you, everyone. Thank you, participants. Have a great day.
Thank you, ma'am. Have a great day too. Thank you.
Yeah. Can I quit?
Yes, ma'am. Sure.
Yeah. Yeah. Okay. Thank you.
I request all the participants to leave from the meeting.